Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This is a short one entitled The Planet X System Object and Space Weather on October 18, 2017. And this article is just a continuation of Article 65, which details the evidence behind there being a stellar core on the outside of Earth's orbit on October 13, 2017. So 5 days later, on October 18, 2017, there were two CMEs, or coronal mass ejections, and these were very close to each other. One was at 6 UTC and the smaller one, was at 624 UTC. And we can see these on the cactus data. The 6 o'clock one is the second one from the top, and it's got a 2 next to it, which shows that it's a potential full halo effect. So that tells you immediately it's quite a strong one. And then the other one at 624 was a smaller one. You can see this one is more widespread, just tells you the position. It's a wider angle. And this was a smaller angle CME. But whilst this one was spreading outwards, and you can see it here, spreading outwards, this is the 6 o'clock one, we started to see the other one from 624. Now we can also see how strong it is from the maximum velocity. So the maximum velocity for the plasma being ejected here is 1,358 kilometers per second. And then the other one, the smaller one, which we can see here, so this is the smaller one, the maximum velocity is 1,041 kilometers per second. So that shows you that it was a smaller CME, not nearly as strong. And there are always these circular shapes in these CMEs nowadays, and if you watched the live stream I did with Scott, we go through it. Why these are there? They are there because they are stellar cores in the sun's corona, and basically the plasma has to go around them, and they move away from the sun with the plasma due to repulsion, and that's to do with the electric field that increases at the point where these events are happening. And that means that under the electrostatic repulsion that then occurs, the object moves away from the sun. And I've also explained before that the gravitational field that we observe is actually an electric effect. It's to do with electrostatic attraction between molecules in solids. It's basically like London forces. So basically everything is due to the electric and the magnetic interaction. The magnetic interaction is what causes stars to form under the Z-pinch effect. The magnetic field contains and condenses the plasma, and eventually it forms into a dense star. And it's the magnetic field of that plasma that keeps on containing the plasma of a star. Our sun is getting weaker because of the effect of these stellar cores, and so it's not able to hold on to its plasma as well as it once did. So these explosions are getting stronger. And we see here, this is the LASCO C3 image showing both CMEs. This is the 6 o'clock one, this is the 624 one, the weaker one. And you can see it was quite spread out, not quite full halo, but as they say, there was potential for a full halo event. Now here we see what happened in terms of solar flares. And there was a B2 solar flare at, we can count here, this on October 18th, this line here is 3 o'clock, 6 o'clock, and 9 o'clock. So about 9 o'clock there was a solar flare. So it seems that these CMEs are happening independently of solar flares. Also the solar flare, it's only a B2, it's not that strong, unless the actual a stronger solar flare happened, and it did not appear on the data because for some reasons it was hidden. But what resulted was a lot of earthquakes at that time. Say 4 hours later, we had this strong magnitude 6 earthquake in Tonga, and there were, as you can see along the west coast of the United States, lots of earthquakes. And usually a solar event will lead to earthquakes because it induces currents inside the earth, and as I've explained many times, earthquakes are electrical events. They're basically due to lightning, subterranean lighting inside the earth. And I have several articles on that. Now the only thing I could find that could generate a B2 flare, a solar flare, was this brightening here on the left side of the sun, in other words, the eastern limb of the sun. We do have coronal holes facing the earth right now. So we would expect a strong, a fast solar wind speed coming from these coronal holes. We have this one here, that one there, one always at the South Pole. Lots of holes, smaller coronal holes here. So we should have lots of fast solar wind. But if we look at the speed of the solar wind, here's the solar wind, it was actually dropping way below normal. The temperature of the solar wind was also dropping, which shows that kinetic energy is dropping. Basically the energy with which the magnetosphere was being impacted by the solar wind was dropping. And that to me means that we were supposed to get fast solar wind. The magnetic field as well did not change by much. It actually went positive. It's only when it goes sharply south or very negative, definitely beyond -10, and here it never went below -5. It's only when it goes below -10 that it opposes the Earth's magnetic field, or the Z component of the Earth's magnetic field, and then the solar stream particles can stream into the magnetosphere and cause a geomagnetic storm. That never happened, and to me it's surprising that the speed went down so low. So this actually is what I think happened. This is a diagram from the October 13th article where I showed that the solar wind stream, even though we could see a coronal hole on the sun, and these coronal holes are produced by these objects pulling on the sun's magnetic field and connecting magnetically with it, and then the solar stream particles flow outwards from the coronal hole, and it leads to a coronal hole being formed on the sun. So on Earth, for a few days before October 13th, the coronal hole could be seen, but the Earth was not impacted by a fast solar wind stream until October 13th. So I think this is what was happening. There was this connection being made with the stellar core, but the Earth was not in the stream yet. Then on October 13th, the Earth went into the stream that comes from the sun towards the stellar core. So plasma from the sun's coronas, spirals along these magnetic field lines towards the stellar core. And so this fast solar wind then was impacting the magnetosphere. Then on October 18th, what I think happened was the Earth reached the point where it was in the returning stream from the stellar core to the sun. So the normal solar wind stream was opposed by the stream returning from the stellar core towards the sun, and this would then lower the solar wind stream as measured by the satellites in the geosynchronous orbit or in the L1 orbit, which the DSCOVR spacecraft is in. So, in conclusion, solar flares and CMEs are happening independently of each other, and this is most likely due to the stellar cores in the sun's corona connecting to the sun, as I have been writing for many months now. The Earth on October 18, 2017 was probably in the opposing solar wind stream from the object outside of Earth's orbit, as this would lead to a drop in the solar wind stream because the normal solar wind would be opposed by it. This is Dr. Claudia Albers, Planet X physicist,